So for today's class, we will finish up chapter 7 here, 7.1, and may definitely start 7.2 here. And then I also will post the key of the midterm and the video that I'm going to make later on today. So you will see what is the midterm key looks like. And if you if you want your midterm back, just email me like yesterday I told you, so that you will get a copy of the email. So you will, and I will email you back with the midterm that I will scan and email to you. So if you do need your midterm back, just let me know by emailing me. Okay. So says no homework due on this Wednesday because last week is your test day, so we don't have any homework due. So we will be continue with chapter 7.1 here. So this is chapter 7.1 that we stopped yesterday. We are going over what we call as finding the confidence interval for a population proportion. So categorical variables is what we are concentrate on in this section when we do proportion. So we stop at number 2. So we will continue at number 2. So requirements. The first question 2 here is asking us, 2A is asking us to do a requirements check for this case, for the finding the confidence interval for population proportions. Again, these are the requirements check you have to perform. Simple random sample is where you hear the word in the question. It has the word randomly selected in order to receive a check. If you don't see the word randomly selected here, you don't get a check here. Second one is a binomial. There are 4 conditions for binomials. You need to know n. Independence is a second condition. 2 outcomes is a third condition, and the probability is the same as the fourth condition here. So if you have all these 4 conditions, then you will check on the binomial. And the last requirement here is it needs to have at least 5 success and 5 failures. So success in this case is your x, or in this case we call it number of success. Based on this question, it's 856. To find the failure is you need to find what you take the n minus x. So you take 1228 minus 856, and you got 300 something. More importantly, these numbers has to be at least 5 or more. So we have that is checked also. And then make sure you also in your test make sure that your requirements here either met or not met by looking at your checkpoints. If all 3 conditions are checked, the requirements are met. If one of these is not checked, then the requirements do not meet. Okay. Question B is where we stop. So we will continue in question B here. So for question B, they're asking us to do what is the best point estimate for the proportion of a medical law precedent drop or dismiss. So if you remember, the best point estimate for a population proportion is called a sample proportion p-hat. So sample proportion p-hat is the best point estimate for the population proportion. So in order for us to do question B, you just need to do what we call as a sample best point estimate. In this case is your p-hat. In order for us to figure out what is p-hat in this case, it is your sample proportion. In order for us to find out what is the sample proportion, the formula is x over n, where x in this case is 856 and n is 1228. So now if you take your calculator and divide these 2 up, you will get 0.697. That will be what we call as your best point estimate. Okay. Sometimes the question gives us a percent, like 70% that we have example above, then the best point estimate is 0.70, or it's given to us in percent. But however, sometimes the question did not give us the sample proportion p-hat, then you have to divide. Okay. So that will be the one that, and it's also in your formula sheet here, where you say sample proportion of BPE, the best point estimate is p-hat in this case, which is x over n. Okay. So just to bring it up, because these kind of questions usually I ask in your test. Okay. What is the margin of error E in this case? That would be the second formula that you need to know. So in order for us to find the margin of error, you have to do the upper minus lower divided by 2. So that is the formula to find the margin of error. So in question C here, where you find the margin of error, where you take the upper limit minus the lower limit divided by 2. Okay. So in other words, you actually need to find the 98 confidence interval first. So this is usually what I will tell my students when you do the find the margin of error. You do not need to follow the order A, B, C, D, E. You can actually switch them around. Okay. So you don't follow A, B, C, D, E. You can actually move them around. You can move them around. So in order for us to do C, let's do D first, because once we found the confidence interval, the upper and lower, then you can find the MOE, the margin of error. So in this case, as same thing happens when you do your homework or your test, you do not need to follow A, B, C, D, E. You can actually, the order is not that important. It's not important, So we're gonna do D first, where you need to find the 98% confidence interval. Again, short form is CI. In order for us to find the 98 confidence interval, in StatCrunch, you have to go to stats, proportion stats. I'm short form a little bit. One sample with summary. Okay, so this is I will tell you why we're going this. Stats is a column that we use here. Proportion stats, because we are doing proportion here. One sample, we are doing only one sample, and with summary means that with no data. So once if a question provides us a data set, or they ask you to import, get it from data set number 30 or 12 or whatever data set that I are going to do, then we do it with data. But with summary in this case means they give us summary statistics where they give us X and N and all these numerical numbers. So if a question gives us numerical numbers, we do it with summary. Okay. Later on in chapter 9, we will do 2 samples. When you do 2 samples is where you break the population into 2 groups, male, female, or Iowa, Minnesota, like if you break the whole population into 2 groups, then we will do 2 samples in this case. Okay. So let me show you where is this at, so you will familiar with this StatCrunch material here. So this is important class. So you go to stat, proportion stats, one sample with summary. This is how you calculate the confidence interval. Okay. They will ask you for 2 numbers, X and N. Number of success is X, which in the question is 856. Number of observation is 1228. And you need to click right underneath there for the confidence interval, because we're not doing performing hypothesis testing. So make sure you move one. And the level in this case is a 98%, because the question asking for 98%. And the method is standard walk, just don't change anything of it. And you hit compute. Again, you notice that the sample proportion that you calculate in question B, 0.697, is there. Okay, so that's why you can always check your answer a little bit here. Sample proportion is the same. Okay, and now what is the confidence interval? The confidence interval is where you do the lower and upper limit here. So your answer in this case is usually put them in parentheses, 0.66667 actually, to 0.728. Okay. Again, as rounding is like your midterms, 2 to 3 decimal places, unless it is specific specified in the question. So if a question asks for 4, then 4. But if the question did not ask for any decimal places, then rule of thumb, usually the rule of thumb says that it's 2 or 3 decimal places. Same thing in your finals. So so make sure you know how to round. So once you find your lower and upper limits from the confidence interval, then we can backtrack it to the margin of error E. Okay. So in order for you to find this margin of error, you take the upper, in this case is 0.728, minus the lower, which is 0.667, and you divide this by 2. Okay. So this is how you find the margin of error in this case. Let's put in the parenthesis one out. Parenthesis 0.728 minus 0.667, and then you divide this by 2. So this will give me 0.031 if I put it in 3 decimal place. So that is your margin of error in this case. Okay. So let me draw the little box here so you know those are your answers I'm looking for. So if a question is a multiple choice question in your test, then you do not need to show me any work. It's multiple choice. If you want, it's fine. But if it's open-ended, this is what I want to see from you guys. Okay. So make sure you guys know how you do this. So very important. Questions, anyone, before we start doing E? So the last question E here is to write a statement to interpret the confidence interval. So how do we write this statement of how to interpret this? Is you look at the confidence interval, which is the one that I draw in the purple box here. So make sure you know how to interpret. We are something percent confident that the interval from lower to upper actually does contain the true value of the population proportion of something. So this is how we interpret this question. This is very important. Again, there is something wrong. All right, so the interpretation say that we are 98% confident that the interval from 0.667 to 0.728, which is again, these two numbers came from your lower and upper, capture the true value of the population proportion. You want to know what's the context? The context is given in the question. If you look at how you find the 9, it's population proportion of all medical malpractice lawsuits that are dropped or dismissed. Okay. So this is the context. Spell a little bit. Medical. So usually these are the few key things that I will be looking for. Definitely those numbers are important. The word confidence is important to us. So make sure you have. Oh my God. So it's hard to do. So the word confidence must have in here. Okay. The word population proportion must be used here. Okay. These are the keywords in this case. The context that you have, these contexts are very important. So again, those are the big keywords that I'm looking for, and the numbers are important. So make sure you guys have all these keywords and context in the interpretation here. Otherwise, you won't get full points. You have to actually write this out. So make sure, again, this is the first time interpreting a confidence interval. Make sure you know how to interpret this, especially in your finals, because I do definitely ask you this. Anyone have any questions here before we continue with question 3, which is very simple.
Did I hear you correctly when you explained that the homework is not due this Wednesday?
Yes, there's no homework due on this Wednesday. Yep, your next homework due is next Wednesday. Yep. Right, so in question 2, the question gives us two important numbers, your n and your x. Okay, so the question 2 gives us n and x. Now, not always the question give you n and x. Okay, so let's read question 3, and you will notice what is the difference between question 2 and question 3. Okay, so question 3, it says that in a Harris poll of 514 human resource professional, 90% say that the appearance of a job is the most important for a good first impression. So this question, it is also a categorical variables, because they're asking us about appearance at the job. When you first attending a job interview, the appearance is very good. First, is a very good first impression. That means how you look and how you wear and how you dress. Those are very important. I think you guys should know that when you guys look for jobs here, especially when you go for the first day interview, when you first meet the company people. So make sure you dress up nicely. The appearance of yourself, clean and sharp and confidence. Those are what they are looking for first. Then they will start the interview, because these are the stuff, again, something you guys need to know. This is important. So 90% people say that. Now, this question, why this is called categorical variable is because it is either yes or no. Okay, so that means that is the appearance of a job is a very good first impression. 90% people say yes, 10% say no. Okay, that's why it is categorical, it's yes or no. Now, this question is a little bit different from question 2, is because question 2 gives us x and n, where you know that we need to put it into your StatCrunch, right? X and n in your StatCrunch. However, in question 3, they give us n, which is how many people they survey. That is the sample size or number of trials, but they give us a 90%. So this is not x. Okay, x is a number, not a percent. Okay, so this is given us by p hat. Okay, again, what is p hat stands for? P hat stands for the sample proportion. Okay, so this is actually is sample proportion. Okay, so this question do not provide us x. Okay, which is the best the number of success. So question A is asking that among the 514 human resource professionals who surveyed, how many of them say that the appearance of a job is important for the good first impression? So how do we do this question A in this case, class? In order for you to do question A, you are actually finding for x in this case, which is called the number of success. Okay, so this is usually the question doesn't ask this, but I ask this over here because StatCrunch require you to put x in there. How do you find x in this case? If you have that formula, so if you need to find the x number of success, you just need to take n times p hat. So this is kind of something we did it before in your first day of class when we asked for how many people have tattoos. Okay, so you take n times p hat. Okay, so you multiply this up. We'll use a multiplication symbol. That star is a multiplication symbol, those who do not know it. So n in this case is 514, and you're gonna multiply it with 90%, and you just need to change that into to decimals. And then you just take out your calculator and you take 514 times 90, 0.9, sorry. So again, you get 462.6. You cannot have decimals because you cannot have 0.6 people. So you have to round this to 463 people. Okay. So this is how you find X. So again, I'm going to point out to you. So there are different questions. So sometimes a question gives us X and N. Sometimes a question gives us N and P hat. So how do we know it's P hat? It's because it is a percentage and it comes from a sample from the 514 people. So this is your sample. So that means this is a sample proportion in this case. So if that case happens, then the first thing you need to do is to find X. And how do you find X in this case is take N times P hat. And then if you get a decimals, you need to do your rounding to a whole number. Okay. Anyone have any questions here how we figure out X here? Question B is to find the 99% confidence interval in this case. So how do you do this? Again, it's the same thing we did it in question D here, but we're not going to do 98. We're going to do 99%. So in order for us to find a 99% confidence interval, you have to go through the same thing as finding 98. You go to stat, you go to proportion stats, one sample with summary. So this is where you're going to find your confidence interval is. And then for the number of success, is your X 463, the one that you just calculate in part A. And then the number of observation is 514. And then you click on the confidence interval and change this to a 99 or 0.99 because the question asked for 99%. And when you hit compute and you get yourself this confidence interval. So again, your sample proportion is very close to 90% because we round the number out. So that's why it's a little bit, I mean, it's close, it's not. And then the lower and upper is your answer in this case. So in order for us to find your 99% confidence interval, it is 0.867 to 0.935. Okay. So again, this is how you find the confidence, 99% confidence interval in this case. And class, I will tell you that this is the easiest way for you to find this confidence interval. If you go and do your homework and do the help me to solve this or do watch the videos in the homework here, they will take you half a page long to find these two numbers, okay? Just to tell you straight ahead right now, we only take, what, 1 minute to figure out your lower and upper limit here. But if you watch the video or help me to solve this doing some stuff in the textbook or in your homework, they will give you, it's going to be a half a page to find these two numbers, okay? Which a lot of you do not want to do a half a page work here. That's the reason why I make sure you guys know what you're doing here. Otherwise, if you've not watched this video or attend my class here, you probably end up doing half a page long here. Question C, repeat question B, but this time you're doing an 80% confidence interval. So for question C in this case, they're asking you to find the 80% confidence interval. Now you're still using the same statistics, the same numbers here. So for us, if you are just changing from 99 to 80%, this is what you do in StatCrunch. You go to the option here, and then you click edit. Okay, so you click on the options and edit. So that means you're editing the numbers here. So everything is the same here. X and N is the same. The only different here is your confidence level. This time they want you to find an 80%. So option and edit is the place you go here. So make sure and then you hit compute. Then you will get yourself an 80% confidence interval. So if you look at the result, they will tell you what kind of confidence level they use here, so you know that you're in the right track. So 80% confidence interval in this case is 0.884. to 0.918. Okay, so this is the 80% confidence interval. Okay. So question D, now you will compare these two confidence interval, 99 and 80% interval, and they ask you which interval here is wider and why. Okay, so that's the question it's asking. Now you need to compare these two confidence interval, which one is wider and why is wider. So let's say that you got a number line. Let's draw so we got 80%, 0.8. I'm just showing you so you guys know where is it. And we got 0.9 and we got 1.0. So that is the highest you can get. For the 99% is between 0.86 to 0.9. So 0.86 is somewhere here and 0.935 is point. So this is 0.867 and this is 0.935. I'm going to use blue as a 99%. This is 99%, the blue. And I am going to use red to figure out the 80%. So 80% in this case is 0.884, which is right here, and 0.915, which is right here. So this is the 80% confidence interval. So now if you compare between the 99 and the 88, the question is asking which confidence interval is wider. Okay. So so you notice that the 99% confidence interval is wider than 80%. So my question to you is that always the bigger level gonna be wider than the smaller level? That is my question is that always the 99, the highest level confident, the confident level that we use is always bigger than the smaller one? The answer is yes. Okay. So next time, if I give you a confidence interval between a 95 and an 85, the 95 is always wider than 85. Okay, so the bigger, the reason why is, this is the reason why here, the higher the level, the bigger the MOE, that causes the CI to be wider. Okay. So majority of it is because of the MOE, okay, which is called the margin of error. So if you use a higher confident level in this case, it will make the margin of error bigger, the plus minus, you know, the MOE that we did here. So so if you make that bigger, then that will make the confidence interval to be wider. Okay. So if you want to do 100%, can someone guess what would be 100% level is? Anyone? Okay, let's try it. So let's go to option and add it. And now we're going to do 100%. 100% means 1.0. 100%. And when you do this, they give you error already, so that means no good, right? So so that means it's above what the error is. So I will tell you that when you do 100% of confidence interval, the level in this case is going to be between 0 and 1. That means it's going to take the whole entire the whole thing, 0 to 1. This will be 100% confident. Why I say 0 to 1? Because if I want 100% confident, 100% means 100% sure. So if I want to make 100% sure, then I will take the entire outcome that it can have. Either you go from 0% to 100%. Okay, so that means you take the fully 100%. And usually we do not calculate 100%. And so this is something that we don't do it. That's why when you put 100% in your StatCrunch, you will get error in this case. Okay. So in StatCrunch, you will get an error message come out because usually we don't calculate 100%. If you do calculate 100%, means it's 0 to 1. That means the confidence interval is even wider. Okay. So we always, the highest we go is 99%. Okay, we don't go higher than. Sometimes depends on the company. Sometimes the company wants to find 99.9%. I mean, you can have that, but usually they don't call it 500%. Okay. Anyone have any questions in question 3? And finally, in question 4 here, this is where they ask us to use the data set number 38 candies. And the Mars Candy Company claims that 16% of its M&M plain candies are green. Use the sample data to construct a 95% confidence interval to estimate of the percentage of all green M&Ms. What do you conclude about the claim? Okay. So I show you 2 ways last time. One way is the question give you X and N. The other way is question give you N and P hat. And the last way is where the question gives us a data set. Okay. So if you have such questions come out, first you have to go into the data set number 38 candies. So go to the data set from the StatCrunch here. Then you will go to number 38 candies here. This is how you go to the data set. Again, we are only concentrate on the red, orange, yellow, brown, blue, and green. These are the M&M's color of candy. We don't do Hershey's and the Reese's peanut butter. So we do not do this. So this is it. And then what are all these numbers? Okay, what are all these numbers? All these numbers. So if you doesn't know what is all these numbers, especially in the test, you can always raise your hand and ask me. You say, hey, David, what are all these number means? Okay, now I will tell you right now. Okay, these numbers are what we call as your weight of the M&Ms. So what is going on here is that the author opened a bag of M&Ms and randomly pick numbers out. So he picked one candy out, and that candy is red color, and he will put it in the weight and how heavy is this red candy, and it came out to be 0.889 gram. I think it's in gram. And then he put it away, and then he picked another candy out from the bag, and let's say that is yellow, and he will measure the yellow candy, and it's 0.853. And he will repeat this through the whole bag. So that's why you get all these numbers here. Okay. So so this is what happens in for this number is. Okay. So the question is that what is my X and what is my N? Okay. Because you need X and N to do this work. Okay. And again, X in this case is what we call as the number of success. Okay. Now, what is the number of success we're talking about is what color? Because in this case, this question is asking for us to find the green color. So we're going to do the green color in this case. So X in this case is how many green M&M candies do we have that he used. Okay. And then N in this case is your sample size. So you have to figure out what is the sample size in this case. So in order for us to find how many green colored M&Ms, you don't add these numbers because this belongs to a categorical variables. You have to figure out count. So look at the green section. If you scroll all the way down, there are 53 green candies. Okay. Again, let me repeat how many green candies in this data set. You don't add these numbers. Those are the weight. Again, weight is not a categorical. Weight is a quantitative. So you have to go all the way down to the green. The last number here is 53. Then that is 53 green. In order for us to figure out the sample size, you have to add all the colors out. So you have to add the red one, which is 45. This is red. You have to add the orange one. Oh, I got color here. I can add this one. Orange has how many? Orange has, let me see. Looks like 82. Yeah, you have to do this. So this is what happens if you have a data set, is you have to add them up like this. Yellow has 41. Okay. Brown has, what's brown color looks like? This looks like red here. Okay, I don't have brown, so I'm going to use this as brown. Brown in this case is 36. And then we got blue and green. So blue is a lot. Blue is 88. And green is 53. So you do need to add the green one. So now you take out your calculator and add all these numbers up. Okay. So yes, this is what happens in 45 plus 82 plus 41, 36, 88, and 53. 345. So this total is 345. This is your n. Okay. And now I'll show you another way to do it too. Okay, this is not just one way. This is also another way you can do it. I shut my calculator off. I do not know. So that is how you figure out the x and n for this kind of questions. Okay. And then the question is asking us to perform a 95% confidence interval. So 95% confidence interval. So in order for us to do that, you go to stat, same thing that you just did on question 2 and question 3. Proportion stats, one sample with summary. The number of success in this case is your x. We have 53. And the number of observation is your n, 345. And you find the 95% confidence, so it's still 0.95, and then you hit compute. This is your 95% confidence interval result is. It's going to give us as 0.116 to 0.192. Okay. 0.116 to 0.192. So if you know your x and n, that's how you do it. Here is another way to do it. So I'll show you another way here. Okay. So you guys know what it is. So if you want to do this, first delete the Hershey, delete the Hershey and the Reese's. Okay, and then you go to stats, proportion stats, one sample with data. Okay, so I'll show it to you. So what happened is that if you want to do with data, because we have data here, but you have to take out those that are not relevant to this question. That's why I have to get rid of the Hershey and the Reese's peanut butter here. I think I can delete the whole thing here. Yep, gone. Let me delete some more. Sorry. So you just highlight this friend of yours and we're gonna delete the whole thing. Okay, so make sure that you only have the colors of M&Ms here, and the rest you do not want it. And once you got this, you go to stats, you go to proportion stats, one sample with data, okay? And we are concentrating on green. So we're gonna put green as your values in. I think this is, and I used 95. I think this is how we do this. I'm gonna try and see it. Okay. See, I need to values in green. Okay, see, I control. Success is in green. Let's try this way. See this work. Okay, it does not work. So this is new to me. I haven't done this before. I thought I can do this, but looks like I still get stuck. Okay, doesn't know what to do. So I'm probably not gonna do this way then. It's not coming what I want to do in this case. So I will not, yep, don't do this way then. No. Sorry, just delete the whole thing off. No good. So I think this will be the right way to do it because I know this is the correct way. The way I just mentioned just now, please totally ignore it. Please do not do that. Otherwise, you get wrong like what I just did there. Then the next question, we still not finished it, is asking us for what do you conclude about the claim 16%? So every time when they ask you about this conclusion, about this 16% or whatever percent they give to us, they're asking us is 16% inside or outside this confidence intervals. Okay. Oh, by the way, I forgot to mention that if you give me this answer in your homework, they will mark you wrong. Yes, I forgot to mention that. This is wrong. And I think some of you know why this is wrong. The question is asking for percentage instead of proportion. Okay. So again, proportion is decimals. So this question is gonna mark wrong here is because it is not in percentage. So the percentage will be 11.6% to 19.2%. So this will be the correct one. So make sure that I totally forget about that. This is correct. Okay. So the 95% confidence interval is between 11.6 and 9.2%. So make sure you read the question carefully in your homework. If they ask for proportion, decimals. If the question asks for percentage, change the percent. Okay. And in order for us to answer the final last question here regarding with is 16% is what you conclude about 16%. You're talking about is 16% is inside or outside the range. If it's inside this confidence interval, then the claim is valid or the claim is good, the claim is correct. But if your percentage is outside this confidence interval, then the claim or the value here is invalid or is no good, is bad, is false, or something else. Okay. Now, since 16% is found inside in between these two numbers, 11 and 19, so the claim in this case is valid. So for this case, the claim of 16% is valid or is true or is good because although the question doesn't ask us reason why, this is the reason because 16% is inside the CI. Again, CI is a short form for confidence interval. Okay. So this is how we do question 4 here. So there are few ways that, as I mentioned, that they will ask in the question. One, they give us xn. The other one is given n and p hat. And the other one is call us to get it from the data set. So make sure you know that there are 3 ways for us to do this kind of questions. So read the question carefully and see how it looks like. And then there are also a few ways they're asking us. Sometimes they can ask us to check the requirements. Sometimes a question can ask to do the best point estimate, find the margin of error. The confidence interval is what usually all questions has. And sometimes a question asks us to interpret the confidence interval. Sometimes the question asks us to figure out which confidence interval is wider. And sometimes the question is asking what you conclude about the claim. So these are the type of questions that they will ask in confidence interval. Okay, so I probably will type it up for you. So maybe tomorrow you will get a copy of it, because these are the few things that the question can ask you in the finals. Usually I will ask you for definitely like the requirement check, and I will ask you for the best point estimate. Sometimes I ask you for the margin of error, and sometimes I ask you to interpret. So make sure you guys know what the question wants you ask for, and then you have to perform that. Okay, so so that is how you do this kind of question in this case. Okay. Any questions before we jump to the next section here? This 7.1 homework is due next Wednesday, which is the 17th. No homework on tomorrow. Anyone have any questions? All right, so far, what we did is all categorical variables, which is all about categories. So that's why we do population proportion, or sometimes we use the word percentage, okay? Population percentage. For 7.2, we are doing population mean. The first thing you need to know is that population mean, when you want to find the confidence interval, is going to be a quantitative variable type, like height, weight, test score, temperature. Those are the questions that they will ask you for this 7.2. And I just want to show you some examples here so you guys can see what is the difference between that. You find out that they have, if you like example 2, this is talking about the weight, okay? This is talking about the weight. So we know this is quantitative. And also you have the word mean, a lot of the word mean coming up. You see that? Okay. Do you see the word proportion or the word percentage in here? The answer is no. You won't see the word percentage or the word proportion in this case, because we are not finding proportion or the percentage. So that's why it's very special in this case. Same thing with question 3. We are looking for the mean pulse rate. So pulse rate is a quantitative variable, and you see the word mean in this case, and you will not see the word proportion or the word percentage here. Okay. Same thing happens in question 4. This is commute times. This is quantitative in minutes, and you are asking to find the mean in this case. Okay. So again, you don't see the word proportion or the word percentage here. Okay. So you see the difference between population mean that is given in this example and the population proportion that we just did here, where you can tell that they will use the word percentage, they will use the word proportion. So there's quite a few words. So there's a few words that you're looking for. Again, this is the word proportion here. So you don't see the word mean in here. Okay, so you can tell that. So this is what happens in my finals, because everything is been jumbled out. So how do you know which is proportion and which is mean? Read the question really carefully and figure out if you see the word proportion or the word percentage that pop out in here. Okay, that will be something that we're doing proportion here. And if you do a mean, then make sure you concentrate this on the mean part. Okay, you guys okay here with this? Now, the first thing when we mentioned about the mean is the best point estimate. Okay, so for the population mean, the best point estimate is your sample mean X bar. Okay, so so when you do the population mean, the sample mean X bar is the best point estimate for the population mean. Last time in proportion, the sample proportion, P hat. The best point estimate is your P hat, which is sample proportion. That is the best point estimate for the population proportion. But when you do the population mean, sample mean is the one that we do. Okay. Now in this section, we are doing how we find confidence interval for the population mean, where the population standard deviation is not known. Okay. So for this part, we always figure out how to find the confidence interval population mean, where sigma, which is called, this is called sigma, symbol sigma, which is called population standard deviation, is not known to us. Usually that means if sigma is not known, that means S is known. Okay, and so you ask me what is the letter S in this case. It is called the sample standard deviation. Okay, sample set is known. So we call this as the letter S. So that means that we know the sample, but we do not know the population. This is usually we do not know the populations because population is too big, but we know sample, draw sample out from the population. So S is known in this case. So so for this kind of finding the confidence interval, we have to introduce you to a new distribution. So in order for you to find this confidence interval, you will use what we call as student T distribution. So last time in chapter 7.1, when you do this, this is actually using what we call as a standard normal distribution Z. So we are using Z in this in proportion. The reason why is because Z stands for the Z score, the 0 and normal distribution with the mean 0 and exception 1. However, when you find this population mean, the confidence interval that we're using here is no longer using a standard normal Z. We're using a T distribution. Okay. Some of you ask me how many distributions do we have in statistics? In the world of statistics, there is a lot of distributions. The most famous one is the Z and the T that you guys learned here. We still have the binomial distribution that you guys learned in chapter 5. And then there are so many more. And then you ask me how much more is it? You just go to stats and there will be Z and T here that you have. We have ANOVA, we have regression, we have all this. Yes, there's a lot, and this is just a basic ones that you have here. This is kind of what we call as an undergraduate level statistics. So you'll be learning all this other distribution if you're going for your stats major. However, if you go on to the graduate level, then you got a bunch more coming out. So I will say around 200, 300 distributions in the world of statistics, and every year it keeps on adding more. Okay. And so this is what happens to the student T distribution in statistics here. So what is a student T distribution that you need to know? Okay, so a student T distribution is kind of like a normal distribution. Okay, but it depends on degree of freedom. Okay, so a student T distribution is kind of a normal distribution. So when I say normal means symmetrical. Okay, low, high, low. Okay, but it depends on one thing: degree of freedom. What is the degree of freedom means? Degree of freedom is a collection of sample data in the number of the sample values that can be varied after certain restriction have been imposed on all the data values. The formula to find the degree of freedom for T distribution is n-1. Now, this degree of freedom is so the definitions, if you look at the definitions of degree of freedom, it is so detailed, and it was like a lot of students say, I do not understand what this sentence means. So I'm going to explain to you in the most easy way so everyone can understand degree of freedom here. So a degree of freedom is actually like, let's say I give you an example. Okay. Let's say that you go grocery shopping, you buy items, you buy banana, and it is $1, example. Okay. Then you go buy tomatoes. Tomato is $2. Again, this is just, I just give you an example. And then you buy broccoli. Broccoli is, let's say, is $2. And then you forget, then you buy one more, let's say onions. Okay. But the price is missing because in the receipt is wet, or you cannot see it, on the ink is gone. But the total of the groceries that you purchase here is $5.50. So the total of the grocery is $5.50, and you bought all these groceries, let's say. So can someone find out how much is this gonna cost, the onions? So majority of you say, yes, David, I can figure this one out, right? Because you take 550, subtract by 221, and you find out, oh yeah, this is 50 cents, right? So so what happened in this case is, this is what we call as degree of freedom, DF, where if you have if you purchase 4 items, and if you know three price of out of 4 items, you can figure it out, because the degree of freedom in this case is n-1. So n in this case is how many items or sample size. So since we got 4, so if you know 3 of this price, then we should able to figure out the 4th one, how much is it, right? But so this is why the degree of freedom for this t distribution is n-1. But let's say that you do not know how much is the broccoli and how much is the onion, but the total is 550. Can you figure out, can you tell me how much is the broccoli and how much is the onion is? Unfortunately, you cannot. Because if you subtract this, then you will find out, I don't know how, I mean, the rest is, like 250. I was like, okay, 250 can be, between these 2 items. So, that's why the formula is not n-2 or n-3 or n-4. It's n-1. And the reason why it's n-1 is because if you know almost everyone except for one, then you can figure out what is the missing value in this case. So this is called the degree of freedom. So it's very important to us in the world of statistics. So so what is a student t distribution looks like? Okay, so I will draw the picture. So as I mentioned, the student t distribution is a normal curve, but this is the special features of the student t distribution. If your degree of freedom is small, like 5, not 5, let's say 3, even smaller, 3. If I say degree of freedom is 3, can someone tell me what will be my sample size n? Forget, the formula is n-1. So if degree of freedom is 3, n is what? N
4.
will be 4. Yeah. So we only got 4 students in this case. But you guys know that, right? Central limit theorem, CLT, says that your n has to be at more than 30. So now you only got 4 students or 4 people here. So why can we still use? So that's the reason why that this is the t distribution is a mutation of a z because of CLT. Because now we are kind of like not doing CLT here because your n is really small. So what happens when you look at the t distribution here? You can have a smaller sample size, like 4. Not supposed to be not following CLT here. And you find out that when you have a smaller sample size or your degree of freedom is small, your tail on the end part here is a little bit thicker. Okay, this is why it's a little bit thicker on the end part. The mean is still 0, but the standard deviation is not 1. It has to be greater than 1. Okay, so for a student t distribution, mean is still 0, but your standard deviation has to be greater than 1. Z has to be 1, but for student t is greater than 1. And if you have a smaller sample size, your tail is a bit bigger. Okay. Now, what happens if you increase your degree of freedom or increase your sample size? If you increase your sample size, then the tail is getting a little bit smaller, but also it's going to be a little bit higher on the top because this missing area will be putting up to the top here. So the degree of freedom in this case probably will be around like 15. Or in this case, n is 16. So if you increase your sample size or your degree of freedom, you find out that your distribution, your t distribution is having a more thinner tail here on the left and right, but it's more higher peak. But the mean is still 0. The standard deviation is still 1 in this case. Now, what happens if you keep on increasing your degree of freedom to even bigger? So let's say that your degree of freedom in this case is bigger, the purple one. So I'm going to draw it right over here. I don't have no room here. So let's say your degree of freedom is 30. That means your n is 31. Now, the good news is when you reach n is 31, CLT is available in this case because your sample size is greater than 30. So what happens in your t distribution here is your t distribution once you reach into this is very similar to your z. Okay, so this is the property that I will bring it up to you so you know what is the t distribution property is. Student t distribution is different depending on sample size. So you can tell that your shape is still a normal shape, but every shape is different depending what is your sample size n or your degree of freedom. Okay, so that is the first thing is. Second thing is that t distribution is a symmetrical bell shape, something like it's a normal distribution. But the mean for the t distribution is 0. But the standard deviation for the t distribution is more than 1, okay? And when sample size get larger, like what we just do from black to red to purple, it's getting larger, your t distribution getting very close to your z, standard normal distribution, okay? So I will say that this student t distribution is used back in maybe 150 years ago, where you don't have 31 students. Like example for this class, right? I don't have 31 students in this class because of the CLT. I only got 15 students in this class, right? So I cannot apply CLT all the time because CLT requires me to have 31 students or more, right? That's what the CLT condition says. However, one of the person developed this new distribution called student t distribution, where you can actually not following CLT. You can just have a smaller sample size and its accuracy is still okay, not too bad. But once you reach 31 or higher sample size, then the t distribution is getting very, very close to the z. So that kind of so this guy who did it is quite famous. So, but he was anonymously used the word student T. His name is called Gossip T. He's an Irish guy. So he was kind of like figure out what is, he doesn't want to give away some secrets that he has. So he doesn't use his name. So he used a very anonymously name here, student T. Until now, which is 150 years later on, his name is still not in here. So you don't see any of his name popping out in here. But if you bring up t distribution, a lot of statisticians knows who you're talking about because t is his last name. So so a lot of distribution statistics use the last name. So if you create a new distribution, it can be like Liu distribution, my last name. So that means that everyone has to learn my name in this case. So my last name. So mostly all the statistics that you see here is using that last name in this case. So this is a new distribution. So we call this kind of distribution as sampling distribution. Okay. So a very important word here. So that means that your sampling distribution for the population mean is T distribution. You can drop the student. I don't need the student T, just the T distribution with distribution. Okay. So, but however, the sampling distribution to find a population proportion, which is this case, so the sampling distribution for the population proportion, we don't do mean here, proportion, is the Z distribution. So when I say Z, Z means it's your standard normal distribution, your Z score. So, so make sure you guys know that if a question in your test or homework asks what sampling distribution you use when you find the confidence interval for population proportion, we always use Z. Okay. However, when you find the population mean, we will use, I will put more word, population mean, where sigma is unknown. So this is what we will be doing a lot here, where sigma is unknown to us. So that will be always a T distribution that we'll be using here. Questions do we have? I will give you some graph so you look at it. So we have some notations that you need to know. The first notation we have is mu. Mu stands for the population mean, while the X bar in this case is your sample mean, or sometimes we call this as your best point estimate. Okay. And there's a reason why we got two best point estimate is because one is for mean and one is for proportion. So you don't get these two confused. And then for the S stands for sample standard deviation. N is called the sample size. E in this case is called the margin of error. Again, the formula for margin of error is still the same thing. Upper minus lower divided by 2. Okay. T alpha over 2 is called the critical value. As you remember last time when you do the critical value on the Z, we do the -2 and the +2. Remember the low and the high? These are called the critical value. And in order for us to figure this out, we use the normal calculator. So for this case, we don't use normal calculator. We will be using a T calculator. So in order for us to, yep, we have a T calculator. So in order for us to do this, to find the excuse me, critical value, you go to stats, calculator T, make sure you put in your degree of freedom, and the alpha is divided by 2 because we got the left and the right, the low and the high side. So you have to divide this by 2, and that's the second box. The first box is empty. And this is how you find a confidence interval here. So I'll show it to you how you find it. Before we go through the find the confidence interval, I'm going to take attendance in this case. So please take attendance here. So I will show you where is the T calculator that you guys did. So you go to stat, calculators, and T. So you got a letter T in here. So this is the T distribution that we have. Okay. I will just show you to you what happens if you have like let's show you have 3. Yeah, let's do 3 first. So if you look at 3, 3 again, look at this is very thick in here. This is -10 and -20. It's a huge, it's really thick here. So what happens if you have 6? Okay, if you have 6, look, this is the scales a little bit smaller here. So it's a bit more thinner. And then if you got 20, it's even thinner. So usually when you have a T distribution, that depends on the degree of freedom. And the higher the degree of freedom, the more smaller it is. You can tell this is very thick. This is from 0 to -50. Don't forget, if you zoom in right over here. So what I will tell you here is that the T calculators or T distribution require to know the degree of freedom. So this question, I did not give you a degree of freedom. So let's say that to do this question, your degree of freedom is, let's say, is 20. Okay, so just make things easy. So usually the question has to give you the degree of freedom, or n in this case. So in order for you to find the 90% confidence interval, find what is the critical value in this case. You go to T calculators. Your alpha in this case is 0.10 divided by 2. Okay, so this is how you figure out what is your critical value for a T distribution for the population being here. Where you take that alpha and divide it by 2, you put it right in the second box. So the first box is your answer, and the reason why you got your answer in this case is not negative, should be plus minus 1.725. Okay, and the reason why that this one show a negative is because you're only doing the low, the significantly low. So the significantly high is the same thing as that number, but it's just a positive. So make sure you guys know that there are two answers when you find the critical value for this case. For a 95% confidence in level, then you use the 0.05 divided by 2. Your alpha is 5%. That will give me plus minus where was that? Sorry. Plus minus 2.086. Okay. And then for the 99% confidence level, which is a 1% alpha in this case, your critical value in this case is plus minus 2.845. So this are how you find your critical value. It's a bit different from the normal calculators that you use in this case, because it's a different distribution. Okay. Anyone have any questions? Well, next will be the requirements. So the requirement here is varies. Two requirements here, SRS and CLT. Okay, CLT stands for the population is normally distributed, or the sample size is more than 30. So this is the CLT condition. Now, as you guys remember that for CLT condition, this can have a smaller sample size. Okay, so because we mentioned that n can be smaller than 30, so it can be 4, can be 6, or can be anything. So what happens if you have a smaller sample size? Then make sure that the sample data is symmetrical. Make sure that the sample data has one mode, and make sure the sample data has no outliers. We call this case the robust case. Okay, so if you do your homework and if you hear the word robust case, the word robust means kind of like exceptionals or optionals. Or this is only happens for this world, for this class, is when your sample size is small. So we call this as your robust case. Then make sure that if you need to check your sample size is small, there are 3 things you check. Now the symmetrical and the outliers, you can check it using box plot. Okay, so if that one is easy to do, you just do your box plot, and if your box plot shows symmetrical means your left and your right is somewhat similar. So this is symmetrical. And no outliers means you don't have any dots at the end there, or or the beginning or the end. So if you don't see any dots, and you find out that if you cut this right in the middle and it's kind of symmetrical left and right, you will check this symmetrical and outlier. So box plot will be doing. In order for you to do one mode, you have to go through the summary stats. Okay, you have to go through summary statistics. The one that you do Control A. So that one that you just did in my test last week. Remember summary stats, you click on summary stats column, and then you do the Control A here. Remember that one? So this is how you do that for this case. So if you are doing checking for one mode, you just do that, and then you click it, and you just go all the way till the end of this So once you see the mode is a multiple mode like this, means no good. Okay. In order for it to one mode, you only have like a number like 2.5. So if you see a number in the mode, say 2.5, then you will get one mode. So that's good news. But if you have multiple modes like what is show up in here, then it was no good. So you cannot, so it's not one mode. So if this three condition about this robust case is met, then a CLT will meet. Okay, so this is a note here. If these three conditions of robust case met, then requirement number 2 will meet. Okay, so this is the thing that what we do here for the robust case is you checking for this requirement 2, the CLT condition. And if you have smaller sample size, make sure you check these 3 special conditions we have here. And if these 3 conditions that you check match, all 3 of these meet, then I will say that then the requirement number 2 will meet. Okay. We'll do an example on this so you guys will see what is the requirements that we talked about. Okay. Now for StatCrunch, so I will again like last time I'll type out in the Word document so we will know what kind of StatCrunch you will use. So StatCrunch in this case, we will use stat tstat one sample either with data or with summary. So I'll show you where is it at. So if you go to stat tstats, because you're using T, we never use Z stats. Okay, so some of you will say, David, are we using Z stats? No, we will never use Z stats. T-stats, one sample, and you have an option here. Either you can choose with data or with summary. How do you know which one is which? Okay. Data only happens if the question provides us the data files, or if you import any data files from your homework. Okay, so that means like this. If you have all these data files, if you want to find the confidence interval for the brown one, let's say what is the confidence interval weight? This is weight of the brown M&Ms. You go to stat, T-stats, one sample with data, and you just click on the brown color one. And let's say you want to find a 95% confidence interval, and you hit compute. This is a 95% confidence for the brown color, which is between 0.867 to 0.89 gram. This is weight. Okay, so this is only happens when the question gives us data set. If a question gives us summary statistics like sample mean, sample standard deviation, sample size, then you do with summary. So if you go with T-stats one sample with summary, you don't import it from the data. You have to key in the sample mean, sample standard, and sample size, which is usually given in the question. Okay. So then you click on the confidence interval and then you compute it, and that's how you do it. So there are 2 options you can use, depends on the question. I can kind of show to you what it looks like. If a question is given us like number 2, this kind of question is going to be with summary. Why I say this kind of question 2 is going to be with summary is because you will be the question gives us the sample mean, sample size, and the sample standard deviation, so you can put it in there. Okay, but for question 3, if a question asks us to import this from the data set, then this is going to be with data. Okay, or if a question gives us a data like this, you have to type this data into your StatCrunch. So this is also data in this case. So this is how you know when do you use data and when do you use summary. If a question provides us data, we use data. When the question gives a summary, we use summary. Okay, summary statistics. But I want to point out in the proportion piece, we always use summary. Okay, we always use summary. We never use data. Remember, I tried to use data in question 4. I make a mistake. It's completely wrong. So I don't think so. That's a way. I might need to learn how to use it with data. I might be able to do it, but I think the most is just with summary for the proportion case. Okay. All right, so that is the summary statistics here, the StatCrunch to find it. Again, if you do not use StatCrunch, your work is going to be half a page to a page long to find this confidence interval. There's a lot of work. Again, I'm teaching you using the quickest and the shortest way. How many ways can you write confidence interval? There are 3 ways. So the first way is always the easy way. So your StatCrunch is always giving you the lower and the upper limit at the very end there. So this is how the third way looks like, which is good. And sometimes you can write in this way, which is blank, mu, and then blank, which is the first way that we mentioned. That means you put your lower and the upper in the case, in the first blank and for the lower and the second blank for the upper. The only difference here is because we are doing population mean, so that's why the symbol that we use here is mu. And if you look at the proportion piece that we have last time, we don't use mu, we use p. Okay, do you see that? We're using p in this case. Okay, so P stands for population proportion. And on this section, we are doing mu, which is a population mean. And then the final thing that we do here is finding using this, the plus minus sign with a margin of error. So this is the third way to do it. Usually the third way is a bit more work, because again, you have to find the margin of error by taking the upper minus the lower divided by 2. And the mean, if it's not given to us, you take the upper plus lower divided by 2. So one is plus, one is minus. Okay. And the interpretation is exactly the same interpretation that we have done before. We are how many percent, 95 or 99% confidence interval that from lower to the upper actually does contain the true value of the population. Now this time the mean, population mean in this case. So last time we do population proportion. This time is the population mean, and then make sure that you have the context behind it. Okay, and the wrong way to do this is make sure you don't use chance, you use the word confident, and we don't use sample, make sure you use the word population. So these are the kind of the keywords that I've been looking for. So some of you ask me, is this interpretation the same interpretation we just did on the proportion? Yes, they are the one that I did yesterday with the 5 stars I dropped. Yes, the only difference here is we don't use the word proportion, we use the word mean. Okay, so that's the only difference between these two. Okay, for the interpretation. Anyone have any questions? We can do question 2. We just straight jump to question 2, so we can so that we'll come back with question 1 on tomorrow. Okay. So question 2 is talking about the weight of 36 Pepsi cans are randomly selected, and the mean is this. The standard deviation is that. You have to find a 99% confidence interval. So question A is asking us to find what is the best point estimate. Okay. So if you remember what we did in the beginning of this section here, to find the best point estimate of the population mean, the best point estimate is the sample mean X bar. So in this case, the best point estimate in this case is the sample mean X bar. Okay. So which is given in the question, 0.8241 pounds. Okay. So another thing you notice is when we do mean or quantitative, it has units. When you do proportion or categoricals, we don't have any units. The only maybe units is percent. So make sure you guys know that sometimes you see, oh yeah, this is a unit, issue is mean. So yes, this is what we call as your X bar. That is your sample mean. This is called as your S, which is called the sample standard deviation. And 36 is called the N, the sample size. Okay. So the best point estimate for question A in this case will be 0.8241. And please do not round this answer. Class, when the question gives you a bunch of decimals in your question, please do not round it. Because if you round it, you get it wrong. Okay. Question B is to find what is the critical value. So in order for you to find the critical value, this is the one that we just did here. To find the critical value, you go to Stat, Calculator D, Degree of Freedom, and then you do this. So we're gonna do the critical value for question 2 here. So in order for you to do the critical value, you go to Stat. Again, not point. Stat, Calculator T. Okay. The degree of freedom that you enter here is n minus 1. We have n is 36, so 36 minus 1 is 35. Okay, and then when you do p x less than, make sure this first box is blank. Second box is where you do alpha. Now, since our confidence interval you're finding is a 99%, alpha in this case is alpha in this case is 0.01. Okay, so you take 0.01 over 2. So how do we do this in StatCrunch? So you go to Stat, Summary Stat, Calculators, and T. And then you do the degree of freedom of 35. And then you do the 0.01 over 2 here. This is how you do this. The second box, the first box, you make it empty. So your critical value for this question is plus minus 2.724. So do not forget the symbol plus minuses here because what you found here is only the low side because you use less than, but the other side is symmetrical, so it should be the same. The only difference is one negative, one positive. And when you do this in your online homework class, your online homework, they don't like the symbol plus minus. So you have to enter your answer twice. One is plus and one is minus. Okay. We'll continue C, D, and E tomorrow. So we're going to end today's class here with the question 2AB. And definitely we'll come back question 1 here to finish up what we have here. And then we will be finish up with this chapter 7. So I would suggest there's no homework this tomorrow, but there is, I think, 3 or 4 homework due next Wednesday. So I would recommend you to start working on your homework here. Don't be, wait till the last minute till, oh, that's next week. So start working your homework. As I mentioned, the homework gets a little bit more difficult than the first few chapters here. As I mentioned, it's progressively getting more difficult. So I would recommend, if you have any questions or anything, start doing your homework early and ask me any questions you have. Okay. So, yep. So that's it for today's